Welcome to the last lecture before the project. This lecture is about configuration management. I delivered my own master thesis about configuration management. You will not believe it, in 1988. I have not been thinking about configuration management every single day of the last 25 years. Fortunately, I've been doing also other things, but I've been following the development of the field, and I can say that configuration management is one of these subfields of computer science that has been stable, that is still important after 30 years, and still have a lot of challenges. So when I say that my slides are inspired by Somerville, they are inspired by a lot of other sources, a lot of other books, papers, conversation, whatever. Recently I found a video on the internet by a professor at the Indian Institute of Technology, which I liked very much. I'd be very grateful when people make this kind of resources available. And so since nobody protested that one of my lectures was in English, I decided to give this lecture in English so I can post my own video as a comment to the video of that guy, which already has 10,000 views and which I believe is quite good. Anyway, this lecture will be filmed, and again I think of making it available also through a connection to that video. So the topics that are covered in the book are change management, version management, system building, and release management. I choose another order in this lecture. I choose to start from version management, going to system building, and ending with change management. Release management, we don't have time today. We will have a lecture about release management after Easter. So we take the same starting point that we take each time. We know now that the important phases are specification, development, validation, and evolution. And where is configuration management? Where do we place it? Each lecture we have placed ourselves somewhere. Configuration management is orthogonal to development, to validation, and to evolution. A synonym of evolution that you find in books and websites, whatever, is operation. It's the time when your system has been delivered at the customer site and is available for use. Is the time when users use the system, find error, and eventually report this error back to the development team. So CM is an orthogonal activity to development, validation, and evolution. CM is concerned with the policies, processes, and tools for managing, changing software systems and the related documentation. So the problems that CM wants to attack, the problems that it wants to solve are those problems that all of you who have been coding in projects that have more than one person have experienced. I change one file, you change another file, we don't communicate with each other, and so we don't know which the right version of the system is. There are a lot of problems that arise from lack of configuration items file. And here I want to say that everybody wants to be creative. I like very much to be creative and to use time in creative activities, but if the infrastructure is not in place, it's not possible to be creative. Creativity will die if there is not a precise ordered structure in which we have to be creative. So think of configuration management as a way of giving you possibility to be creative without losing your time, your energy, your communication time for fixing problems that could be solved automatically if a configuration management system was in place. I told you that the release management part will be attacked later. In fact, this video has been already, by an industry person, has been already being played and recorded in studio by the multimedia people. And if you want, you can access it, not copying this link now, but accessing the slides that are available in It's Learning. So you can open the link and see the video about release management. Release management is not crucial for you to know before your project, but version control is very important that you understand before you start your Forelesning project next week. So we start. This is the definition that the book gives about configuration management, version management, sorry, because as I told you, we start from version management. So we go to building, and in the end we have change management. The big part of the lecture will be here on version management, and I try to give you an example that is an alternative to the one that has been given in the book, that is about our own course, about the management of the files in our own course, so that we can have a common understanding about what we are talking about. Think of the first time I came here with my UML lecture 1 month ago. I had with me a file, a PowerPoint file that we call UML slide, if you remember. I have with me some violet file. I had at least an activity diagram. I had a class diagram. And I had at least a use case diagram. You remember that when I first make available the documentation for the first lecture, I give on It's Learning this item. But the item I gave to you, they were the result of a timeline. I have been working some days to produce this object. I did not produce everything like this at first time. I had been working with the first version of the slide, but so I was not so satisfied. The day after, I changed my slide by, for example, adding an example. And while I was doing this, I was here and I was producing my first violet activity diagram 1.1. I was producing violet class diagram 1.1 and maybe violet use case 1.1. But so the day after I wake up, I say, no, my violet use case is not good enough. It doesn't have all the actors that need to be modeled. So I make a change. I add another actor. And I produce something that is called violet use case 1.2. And so I was not satisfied. Again, one of the use case was redundant, it was too much, and so I remove one of the use case and I produce violet use case 1.3. But then, when I make these changes, I found out, oh yes, but so if I have less actor, I should remove that class that had to do with that actor is not relevant anymore. And so I make a change here, and this violet class diagram becomes violet class diagram 1.2. This is something you do all the time. When you code, you change one file, so you change another file. Sometimes you give new names to your file to record this evolution that your items have during the time. But so it comes. And so to reflect all those changes, I have to import again the pictures in my PowerPoint. I make a final PowerPoint that is called UML slide 1.3. So it comes the day of the lecture. After so many years, I still wake up very early when I have to give a lecture to many students as you, and I have to say, okay, now what is my baseline? What is the system I'm going to give to my student? And so I decide, okay, this and this and this and this are the last version of my items, are those that I deliver to my student as a baseline to receive the documentation about UML. In addition to this, I always tell you that you have to look at the Ian Somerville book. And in this particular case, I told you that you had to look at the Violet manual that is available on the internet site. So this is what an example, a practical example of configuration item. Each of these is a configuration item. Each of these is a new version of the configuration item, and these are somehow external libraries that I cannot change because it's not, they are out of my control. Like in a software project, we have external libraries that we include in our project and we don't change, but we only link together with the software we produce. So we go ahead and we try to look at this text. Now it should make more sense. Version management is the process of keeping tracks of different versions of configuration items. Code line, this one is a code line. This is another code line. This is another code line. And it also involves ensuring that changes made by different developers to these versions do not interfere with each other. And in this example, point 2 is not so easy to see because it's only me somehow for the time being who is producing these slides, but we will see better examples about point 2. Therefore, version management can be thought as a process of managing baseline. This red one is our baseline for lecture 1. You understand that each time I have to come here and give lecture, so I produce new configuration item, I produce the PowerPoint for the project management slide, and then I produce the file for the open project tools. I produce the Excel file. So I produce new items, and these items live their life. They evolve in time. We get new versions and we get new baseline. And this is exactly the same that happens in software projects, where new items are created and old items are changed, and new versions arise from this item. So the notion that we have to understand are configuration item, version, code line, change, and baseline. In this simple example, we have all these concepts that I have told to you. In the book, there is this example. I think it's a bit more boring than mine. He writes in the book, in figure 25.6, the configuration items are 3. They are A, B, and C. Very fantasy, with a lot of fantasy. And so A is a configuration item. A 1.1 is a version, and analogously A 1.2, A 1.3, B 1.1, they are all versions. And each arrow denotes a change, and the baseline are baseline V1 and baseline V2. There is a small error in the book, because that A should be something like A.1 or A.2 or A.3. It should be a precise version, not the name of the configuration item. Everybody does mistake, and it's not a big issue, but there is a small mistake in that figure that you can note down. Libraries and external components are something like, in our case, the book or the Violet manual is something that is part of our baseline, but we don't have control over their evolution. Yes, so a code line is a sequence of version of source code or other configuration item. So again, this is a code line, 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 but this red one is a baseline. The baseline specifies the configuration items version that are included in the system, plus a specification of the library used, configuration files, etc. Exactly as my red snake that includes configuration items, their version, and some files that are external to my system. A baseline may be, I specify this baseline by drawing something. When you will make your system, you are used to make small systems. Some of you are used to make big systems, but according to what you have learned here at NTNU, I can expect that you have made small system in object-oriented programming course, and this system have maybe 3 files, so you don't need to use so much magic to describe how your system is made. But for complex systems that have hundreds, thousands of files, you need a configuration language to express how your files interact with each other. And a classical way of expressing this relationship is through the standard language XML. Why it's important to describe baseline? Because, for example, in my case, I could, in principle, be asked by NTNU administration in 2 months to rerun the FELES project. I hope not, but it could happen. And so if a bunch of students come and I have to enable them to start the FELES project, I should reconstruct the baseline of the documentation you get today, all the items and at the version you are today. I should be able to reconstruct all this system for the new students that come in 2 months. And this is exactly the same that happened in the software industry. When I have built a baseline for a customer, I give the baseline to the customer, but then after a couple of months, I have to work again on that particular baseline because, for example, the customer have found an error, and so I must be able to reconstruct the situation at the time I gave the baseline of the system to the customer. And then it's very good to have a language that describes the baseline and not only some informal drawing somewhere. So all of this is the theory of version management, but what researchers and developers have been working at is trying to provide automatic support to version management so that people don't have to reinvent each time how to manage evolving versions of their items. And these version management systems, I have already mentioned to you that the 2 most used, as far as my knowledge, are SVN and Git. In its learning, we have published a tutorial for SVN and a pointer to a set of resources that we believe are good for learning Git. And these systems, they are different, of course, but they both implement these functions that are version identification, storage management, change history recording, and independent development by different developers. And we will see how these functions are described at an abstract level, and I also try of giving you an example of how these functions are implemented in Git that I believe is simpler than SVN, but yeah, it's my opinion. And yes, so this is an abstract view of a version management system, a generic one, as we find in the book. A system like this has a repository, has a big database in which all the configuration items are stored together with their version. And we say that so in this way a system implements storage management because it implements the storage of this version in an efficient way. In the old days, the storage management was the most important function of a version management system because in the old days disk space was very expensive. So when we changed the file, we did not want to copy the whole version of the new file, but we wanted only to store the delta, the difference between the old file and the new file. These storage management problems now are less important because disk storage is not as expensive, but efficient version management system has a way of optimizing this storage management that we don't go inside. I will not ask you in the exam how do Git or SVN implement storage management, but you should know that these systems have efficient, intelligent way of saving versions of the same item. So independent development by different developers. What does it mean? It means that at a certain point, if you are 4 or 5 persons in your group, each one should be able to work at the system. Of course, you have to be smart at a design architectural level and decide this module is Alice module and this other is Bob module and make decisions so that different persons work on different parts. But it happens that something is in common, and so we should have mechanism in place to manage this sharing of resources. You see here that this Alice is working on A and B, and Bob is working on X and Y, but we have this C that is common to both Alice and Bob, and the version management system should allow people to work on the same configuration items by helping them not to make mistakes when they use the same items. We are all used of using Dropbox. I'm sure most of you are using Dropbox, and you are used to get a message when you try to open a file. The system say, now be aware that Jon or Maria are using that particular file. This is a mechanism that helps multiple developers, multiple users to work on Dropbox, but Dropbox is not enough to manage big software projects. I come back to this SVN, Git and Dropbox later, but now I want you to pay attention to these two commands, check in and check out. These are commands that at an abstract level mean that check out, I take from the common repository a working version of the baseline I want to work with. Check in means now I am ready with my changes. I want to play my change back to the system. And different systems, now we will see how Git call this operation. Different systems have slightly different words for check-in, check-out, workspace, and repository system, but once you have understood the logic of this, you will be able to use different systems. Each time I enter a new project and they want us to use some European projects or national project, whatever, and I get, now we will use this tool. Oh no, I have to learn it. But when you know the concept behind, you will be able to learn a new system. And this is why I don't want to make a precise choice about which tools you should use. You should learn the concept, and so you should choose one of the tools you would like to choose. So change history is something that, of course, the system can help us in managing, but it must be us that each time we make a change, we tell the system why we have made the change, what this change wants to achieve, because the system cannot deduce what is in our mind. So this is one of the many tutorial about Git that you can find on Code School, wherever you look for information about Git. Here is very simple. In this part, you can tell Git how to create a new repository and to clone a local repository. It is the operation you do when you go from here up there. You clone a local repository in which you want to work for yourself. So add and remove, here is where you take file and you add to your repository, and commit is where you take file and you check them in back to the local repository. This is a very simple mapping that can be understood by playing sometimes with the system you choose. It's important that you understand this picture, because this picture says, okay, I have a common repository, I have a way of taking out the files, working with my files without disturbing other people that are working with the same file, and at a certain point I will commit them back and my changes will have effect to all the developers that are working with the system. So this is the some Git command. There is another concept that is very important in configuration manager, that is this concept of branching. And in my example, imagine that I am asked to give this lecture in a foreign university, so I have to remove all the Norwegian words I have in my files. And so what I have to do, I have to branch at a certain point, because here I also have, I have to branch and say, okay, here I go ahead to improve the slides for my Norwegian student, but at a certain point I have to make a new version that only include English words or Italian to give my lectures to in another country. So I divide my path of development in two. On the one hand, I continue with Norwegian. On the other hand, I go ahead with English and maybe get help from somebody else who develop these slides in English. But so I come to a new semester and I say, okay, the examples that have been added in the English versions are very good. I want to incorporate them in the Norwegian version too. And then I have to have the possibility to merge the Norwegian path with the English one, and I should then have the possibility to merge the two how do you call them? The two branches. This is the explanation of the branches that I have given to you on this picture, and this is the way in which Git implements branches. It's very intuitive. Create new branch, you have this command git checkout -b. I feel, when I read this command, I feel very nerd. And so switch to master branch. I can switch while I work. I can say, okay, now I don't want to work on today I want to work on the English part of my slide, or I want to work on the Norwegian part. I have a way of telling the system which branch I want to work. I have a way of merging my paths, my branches. Is not always unproblematic to merge. Those of you who have tried, those of you who will try, will see that merging different branches of the same items is not always magic as it appears in book, so try. And so this tagging, what is called tagging in Git, is what is called change management. It is called change history recording in theory. So when you tag, you give to the system information about which kind of changes you have made, so that by status command you will be able to retrieve the history of your changes. Okay, so tagging is change history, implements the function of change history. Okay, we finish with version management. I hope it was understandable, the connection between the theory and Git and my slide example. So we switch to system building. We have been talking a lot about system building, both when we have in the week when we have been talking about testing and when we have been talking about agile development, because building is a very central concept in both testing and agile development. Those of you that have followed the lectures about testing have for sure an understanding of the building process. Build means create an executable software system from the different source files and the different libraries that have to compose the system. And building in professional project is done by having a description, a configuration description used to identify a baseline that is also used by the system building tool. If we have been talking about JUnit, we have been talking about Ant, being JUnit a testing module and Ant a building module. All of this can be integrated on top of Eclipse to automate, to improve this process of building. So this slide is something that we saw already when we were talking about design and implementation. Now it becomes more relevant because now we know the theory behind more tools. Like, for example, today we have been talking about Git, and now we are talking about Ant, that is a simple tool that enables you to describe configurations so that you can automate the building and rebuilding process, so that you can put in practice what we have heard in theory by, for example, the two Accenture guys that come here and say, we run automatic testing at night. How do? They don't have people there writing, compile this, compile there, compile there, but they have some scripts that are made in, for example, XML by a tool that is equivalent of this Ant. Okay? Build platform. Here it's important to understand another thing. In object-oriented programming, in a course like object-oriented programming, a first-year course, you learn how to program alone with one machine. In a course like this, we are talking about development that happen by many users and by many machines. It will not be so much the cases for your Felles project, because in the end, when you show your system, when you show your system to the assistant, your system will run probably on your own computer. But in big projects, we can have situations in which each developer has one computer. And so you have a common server computer and a target system that could be, for example, the weather station, that could be a mobile phone, that could be another example that I will show you now. So think that when we are talking about building, we are talking about complex situation in which there are many computers, one computer per each developer, one server computer that is the platform where we compile all the files, and a target, one or several target systems where we deploy our system. If we understand this, we will, and we understand this picture here that gives the same situation that I depict on the table. I have a development system, with the development tools of the single developer. So I have a server where all the files of all the developers are built together, and they have a target platform that can be a mobile phone, that can be something like this. In a project we have run together with my students a couple of years ago, we were working with a microprocessor that is called Arduino, that some of you may have heard about. And in our case, we were working with a particular instance of Arduino, that is an Arduino LilyPad, that is a computer that you can sew on your clothes. So you understand very well that when you are dealing with such computers, you cannot program nor compile on these computers, but you have to program and compile on other platform and then send your executable to the small microprocessor where the system will run. Having said that, this is an abstract description of a development environment in which I have the most important thing is, of course, the executable system. This is the goal of the whole story. We want to produce an executable system that is working, but in order to do so, we have to have in place a mechanism of testing, hopefully automated. We have to have in place an automated building systems that act by help of compilers and tools. We must have some configuration files that tell to the system how to build, and we must have the source code files that are those that are produced, tested by the developer, some data file, the input to our system, and some libraries that are those that we do not change, but we reuse from other sources. So this is the picture 25.12 in our book. If you look at this picture here, tell me, don't tell me, but think, why do we have in this picture build and test system 3 times? If you have understood all we have been talking about before, you will understand why we have 3 times build and test. Think about it some seconds, and so I will explain to you why we have it 3 times. We have build and test 3 times because first, when we check out a local copy of the files, when we want to implement a change, this agile development that want us to test all the time and to make increments of change. Okay, I get the message that I have to implement a change. What do? I take my copy of the files, of the configuration items in my local repository. Before I do anything else, I build the system and I test the system. Because if by mistakes of some other people, the systems that I get doesn't pass the test, so it doesn't make sense that I start to implement my changes. And this is something that has happened to everybody, to me several times in my small project, whatever, that I start to change something and I don't realize that I'm working on a version that doesn't work when I start, and so it's a mess because I don't know if it's me who have made mistake or if I start from something that did not work. So be sure before you start to make changes that your starting point is correct. So you check out, you build, you run the test. If things are going well, so you can go ahead and implement your change. Oh, sorry. This make changes, and then after you have made your changes, you build and test again. Of course, this everybody knows that after making changes, we have to build, to compile, and to run test. If the test doesn't pass, I have to go back here and make my changes again. When finally the test will be okay, so I can check in the build server I can check my changes in this big platform where all the configuration are, and I build the system again and run the test again, because I have to check that the changes work not only on my private workspace, but they work with respect to all the other files made by the other developers. And then I build and test the system again here on the server. If things are going well here, so I can commit my changes to the version management system, and I can say that I have built the server version of my system. So these pictures is not some rocket science, but it's important to understand why there are 3 times this build and test, and it's not so easy for us if we have only been working at system alone with one machine. So I say, why should I build and test 3 times? Am I crazy? It's because there are all this level of development, and so I have first to build and test to ensure that the version I want to work with is correct. Then I make my change, then I build and test. If the tests are okay on my platform, I put my files back to the server, and then I build and test again, and only then I can commit all the changes to the repository. Daily building, the Accenture guy were talking several times about this night building. The book is talking about daily building, but it's exactly the same. It's a routine, is a procedure that an organization or a group like yours can have and say, okay, we build, we compile each day at 2 o'clock. We want everybody to have made changes by that time, so we build at 2 o'clock. Or we can build at 9. It's a piece of configuration management planning to decide when and how we want to run our build. The last point in our lecture today is this change management. It's not important for the purpose of the FELES project, so we go a bit fast about change management, but it's important for the purpose of the exam. For example, at the exam you could get a question like this that say, give requested change for a given system. So this is the input you get at the exam, and as output you have to define this, that is right change assessment and estimated effort. I give you the description of a system, so I give you something like this, a change request form that describes which kind of requested change we want to implement, and I ask you to make a change request form that describes the assessment, the evaluation of the change. Is this change difficult? Is it possible to implement? Is it impossible to implement? How much time will it take to implement this change? So it's a kind of small project plan about a very small project that has the purpose of implementing one change. So be sure that you don't need to understand many change request form, but be sure you understand that. If you Google change request form, you will find a lot of change request form by Microsoft, IBM, whatever. They look all very much like this, and you can get more examples, but it is again not the point to see 12 change request form. The point is to understand very well this one. What does it mean to assess a change request form, and what does it mean to plan for something to actually implement the change. So in the book you have a very good table that summarizes all the CM terminology. I suggest that when you choose a tool, be it SVN or Git or whichever tool you choose, that you map the terminology of the book into your own terminology, so inside the group you will know what you are talking about. And I conclude with 3 possible exams questions in order to make this even more concrete. if you get the question, how do you judge effectiveness of configuration management? How do you judge if the configuration management procedures, policies of an organization are good or not? It's simple. By the numbers of defects reported due to incorrect configuration management. And also in your group, if the problems you have arise from having conflicts on file, from having compilation on files that are not updated, having conflict between different users, so it means that your configuration management system is not good. CM is an umbrella activity during development and operation. Is it true or false? It is true, but you could have said it is false because I want to see testing as an explicit phase. So in multiple choice, you will get always true and false. But if it is a more open question, you could have commented, yes, but where is testing? Configuration management is very important in testing phase 2. CM plan is not part of project planning. Is it true or false? It's false, because we saw already when we saw the planning of the plan for Eclipse project that CM was part of the planning, and because I tell you that planning for CM is a very important part of project planning. Last question, source code files, requirements document, acceptance criteria, models, test cases, external libraries are configuration items that must be versioned. True or false? It's the last one, so you don't see me for more than 1 month. Please answer. True or false? What do you think? Okay, so I answer. It is false because the external libraries are not subject to our versioning. We don't change the external libraries, we don't check them in and out because it's something that we don't have control over. With this, I conclude this lecture. And I wish you good luck with the projects, and for any questions, contact me or Hans, that we will try to help you as much as we can. Thank you.